Now in this lecture we are going to discuss about the features of action potentials from different parts of the cardiac tissue. Now basically we have got two types of tissues. One is the conductive tissue, another is myocyte or myocardium, atrial and ventricular myocardium. Now in so far the conductive tissues are concerned, the action potential of all the conductive tissues are the same except for the duration and conduction. Now if we see SA node, that is the typical example of all the conductive tissue present in our heart. So now start with the SA node action potential. There is a resting membrane potential and then followed by the resting membrane potential is minus 60 millivolt, and from there it starts as 0 phase, 3 phase, phase 4. SA node and AV node and all the conductive tissue has one thing in common, that they have got pre-potential, that is phase 4. The name of the phase 4 is pre-potential and it lies between the two action potentials. It is a upward going curve, not like resting membrane potential horizontally, but it moves up and reach to a level of minus 60 millivolt. Then it triggers another action potential and it is repeated. So now go to the 0 phase. 0 phase is slow depolarization caused by calcium entry through L channel, that is long lasting channel. Then phase 3 is the repolarization due to potassium going out. Then remember, point to be noted, that all the places the depolarization is caused by sodium entry. Here it is through calcium entry. So 0 phase is because of the slow entry of calcium through long lasting channel. Then phase 3 is the repolarization, potassium goes out. Then phase 4, that lies between the two action potentials, and this is slowly depolarizing potential. This is also known as pacemaker potential. So these are the same thing: pre-potential, slow depolarizing potential, or the pacemaker potential. Now let us come to the muscle side. In the muscle, what we see, that there is no pre-potential. Instead there is only resting potential, that is a horizontal record. Now here the resting membrane potential, whether it is ventricle or atrium, is minus 90 millivolt. Now if you see the two, atrial and ventricular action potential, you will see that the phase 2 is more longer in ventricle than in atrial action potential. That is the difference. Otherwise, it is nearly the same. Now 0 phase is due to the rapid entry of sodium. Phase 1 is very small. Sometime you may not find or miss it. This is because of the sodium entry when depolarization reaches the peak, the sodium channel is closed, and then the graph come down as wave 1, which is due to early repolarization because of the potassium going out. Now then comes phase 2, that is the plateau phase, that is the horizontal line that you see. Now phase 2, if you see, if you draw, then it corresponds to zero potential. So phase 2 is a horizontal line, and this is because of the entry of positive ion, calcium, and exit of potassium from cell to outside are balanced, and because of the balance, the graph or the record is sustained horizontally, and that is, it is known as plateau phase. Plateau means flat phase. Now we will carry on with more explanation in next lecture.